Let's have another example, problem number 2.
Teacher wants to determine if there is any substantial relationship concerning the result in mathematics score and in the science score. The numerical values are in the table below. First step is to identify the null and alternative hypotheses. Since the degree of relationship is not stated in the given problem, so meaning to say po our null hypothesis is r is equal to 0 and the alternative hypothesis is r is not equal to 0. And for the statement form of the null and alternative hypothesis, for null we have there is no significant relationship between the mathematics score and science score. And for the alternative hypothesis, we have there is a significant relationship between the mathematics score and science score. For step 2, for problems under person R correlation, we have to identify the alpha level, the number of tailed tests, and the degrees of freedom. For the alpha level, as you can see, it is not stated in the given problem. So if the alpha level is not stated in the given problem, then automatically the alpha level for that given problem is 0.05. The number of tail tests will be determined with the basis of the mathematical symbol used in the alternative hypothesis. So, in the alternative hypothesis, for this given word problem, the mathematical symbol used is not equal sign. So, therefore, the number of tail tests for this problem is 2 tailed tests. For the degrees of freedom, the formula is n minus 2. So, n symbolizes or represents the number of paired data given in the problem or in the table. Substituting the value for n, since we have 15 paired data values in the table, so our value for n is 15, and substituting, we will have 15 minus 2. And simplifying, we'll have the value of degrees of freedom as 13. Step 3, identify the statistical test that you're going to use for this given word problem. For the statistical test, it is person R correlation because as you can see po in the given word problem, we are looking for the relationship between the two given variables. If that is the case, we are looking for the relationship of two variables, then automatically the statistical test that we should use is person R correlation. Step 4 is the computation. Let me show you the manual computation first and solving for the summations of the variables that we have, and then later on I will just show you the shortcut method in getting the summations of the variables. Just like what we did in the previous example, we must construct a column for x times y and another column for x squared and another column for y squared, and then fill in all the necessary datas. And after that, we have to get the summation for each column. For the column of x multiplied by y, all you have to do is multiply the numerical values in the x column by the numerical values in the y column. So for the first row, we have 56 times 99. The answer is 5,544. Next row, we have 46 multiplied by 97. The answer is 4,462. Third row, we have 44 times 89 and the answer is 3,916. Multiplying the numerical values in the x column by the y column, the remaining values will be this one. Next is for x squared. All you have to do is square the numerical values in the x column. So for the first row, we have 56 multiplied by 56 or 56 squared. The answer is 3,136. Next numerical value is 46. So 46 times 46 or 46 squared. The answer is 2,116.
For the third x value, we have 44. So 44 times 44 or 44 squared, the answer is 1936. Doing it for the rest of the x values, we will have the answer as this. And then for the last column, we have y squared. So you focus on the column y and you have to square those numerical values. So for the first y value, we have 99. So 99 times 99 or 99 squared, the answer is 9801. Next y value is 97. So 97 times 97 or 97 squared, we have 9409. The third y value is 89. So 89 times 89 or 89 squared is 7921. And squaring all the remaining values for y, we will have the value as this. Next is to get the summation for all the columns that we have. So for the first column, the summation of x is 709. We got 709 by adding all the values in the x column. Next is adding all the values in the y column, and the summation of y is 1431. Next is you have to add all the numerical values in the column for x times y, and the summation of x times y is 67,707. Next, the summation of x squared. So adding all the numerical values in the column of x squared, will have 33,769 as the summation of x squared. And for the last column, adding it up, we will have the summation of y squared as 136,641. If you cannot follow po the instructions here and you cannot manipulate your own calculator, all you have to do po is send me a picture of your calculator and from there I will just guide you. Shortcut method for problem number 2, we press mode and then stat and then a plus bx. Then we input the values 56, 46, 44, 43, 48, 45 equal sign, 49 equal sign, 46 equal sign, 52 equal sign, tapos 48 equal sign, 55 equal sign, 43 equal sign, 42 equal sign, 44 equal sign, 48 equal sign. You just have to be careful in inputting the values because if the numerical values are incorrect, the calculator will still give you an answer, but the answer is incorrect since the inputted values are not correct. So for the y column, we have 99, 97, 89, 95, 96, 92, 93, 94, 98, 99, 94, 93, 95, 98, 99. Then after inputting all the values, you press on and then we will compute for the summations of those variables. So we press shift, then stat, and then sum. Then let's get first the summation of x. Then you press 2 equal sign. This is the summation of x. Next, summation of y. You repeat the process. Shift, stat, sum, and then summation of y. Equal sign. This is the value for the summation of y. Next, summation of xy. So, shift, tapos stat, and then sum, and then summation of xy, we have 5. equal sign, this is the summation of xy. And then, for the summation of x squared, we have 1 equal sign this value. And then, last one, for the summation of y squared, we have this value. And then that's it po.
Now that we know the values for the summation, we can now substitute those values in the given formula for us to get the R computed. So again, here's the formula for the R computed. Substituting the values, we will have 15 multiplied by 67,707 minus the product of 709 and 1,431 all over the square root of the product of 15,000 multiplied by 33,769 minus 709 squared and 15,000 multiplied by 136,641 minus 1,431 squared. I discourage you po to directly solve this in your calculator because of the amount of numbers that we have, and I'm not really sure if your calculators can parang like you can input everything in your calculator. So I highly suggest you compute for the numerator first, and then you simplify the denominator, and then you divide the numerator by the denominator, and then that's the time you can compute for the R computed.
For the numerator, we have 15 multiplied by 67,707 close parentheses minus open parentheses 709 multiplied by 1,431 tapos equal sign. This is the value for your numerator. And then for the denominator naman, square root of open parentheses 15 times 33,769 minus open 709 close squared tapos close open 15 open 136,641 close tapos minus open 1431 close squared close equal sign. This is the value for your denominator. And then solving for the R computed, we have 1026 all over 2673.07 equal sign, we have 0.38.
Step 5 is the decision rule. Decision rule for person R correlation is reject null hypotheses if the absolute value of the R computed is greater than or equal to the absolute value of your R tabular. Identifying the R tabular, just like what we did in the previous lessons, we have to go back to step 2 and recall the alpha level, the tail test, and the degrees of freedom. Since the degrees of freedom is equivalent to 13, then we have to draw an imaginary horizontal line passing through 13. And since the number of tail tests is 2 and the alpha level is 0.05, we have to align 0.05 in the second row and draw an imaginary vertical line passing to 0.05 in the second column, in the second row rather. And the intersection of those two imaginary lines will be the value for your R tabular. Substituting the values for R computed in R tabular, the decision rule will be reject null if the absolute value of 0.38 is greater than or equal to the absolute value of 0.5140. Step 6, identify if we have to reject the null hypothesis or we fail to reject the null hypothesis. To check whether we reject the null hypothesis or we fail to reject the null hypothesis, we have to go back to the mathematical statement in the decision rule and check if it is true or false. So going back, we have the absolute value of 0.38 is greater than or equal to the absolute value of 0.5140. Extracting the absolute values, we will have 0.38 is greater than 0.5140. So obviously po, 0.38 is not greater than 0.5140. So meaning to say we fail to reject the null hypothesis. Next step and last step for this given problem is the conclusion. Since we failed to reject the null hypothesis, the basis for the conclusion is the null hypothesis itself, and that is there is no significant relationship between the mathematics score and the science score. And to verify if we really don't have any relationship for these two variables, we have to check the level of or the degree of the relationship between these two variables just to verify if in the degree there the result will also be there's no relationship for these two variables. Define the degree of the relationship, the R computed is 0.38, which is in between 0.30 to 0.50. Therefore, the interpretation is low positive correlation. So, there's a possibility for relationship, but the um, correlation or the relationship is very low. Meaning po, it is still congruent with the prior conclusion that we have na there's no relationship between the two variables. Our conclusion, the final conclusion will be there's no significant relationship between the mathematics score and science score, and there is a low positive correlation between the two variables.